Amy and I are here today to talk about thriving in production with GenAI, lessons to successfully scale your data layer. I'm Nina Lopatina. I'm a staff developer relations engineer at Unstructured. I've been at Unstructured for about a year, and for the last 5 to 10 years have been working primarily in NLP and language modeling across startups and venture capital. And prior to that, I did some years in neuroscience research, where I started my career in machine learning. And I'm joined today by Amy.
Hello, everyone. My name is Amy Gate. I am a principal solutions architect at Elastic. I have been there 5.5 years, and I have a background in observability, in AI search, and have a background in computer science. So thank you, everyone, for joining.
Yeah, and we'll go over our agenda for today. So we'll talk about how GenAI systems got to survival mode, and we'll go through ways to tell if you're surviving. And then we'll talk about what it means to thrive in production and how to build streamlined ETL pipelines. So even processing complex unstructured documents. And then we'll talk about how you can leverage unstructured data within Elastic. And then we'll both do live demonstrations. I'll demo the unstructured platform, and Amy will demo RAG in Elastic. A little bit of housekeeping before we get started. If there's something that you want to share in the chat, that goes in the webinar chat window. If you have questions that you'd like us to answer, you can put those in the Q&A box. And if they're easy, short questions that we can just link some documentation to, we'll answer those in writing. Otherwise, we'll answer them live. We also got some pre-submitted questions, and we tend to do the live questions first and then the pre-submitted questions toward the end if we have time. So if you want to submit your question again, it'll get answered faster that way. We'll send the recording to your email after we wrap up. And at the end, we'll share information about how you can start a guided proof of concept with Unstructured or Elastic to learn more after the session. So a little bit of an intro on Unstructured. We're a Series B startup, and we have a lot of folks already using the product. Maybe some of you in this webinar are already using it and want to learn how to do so even better. And that's between our platform, our API, and our open source.
So Elastic, I hope some of you have used it, but it's been around for about a decade. Elastic, it got started as a logging platform, as a search platform. It is a document database that excels in searching not only the types of documents we're going to be showing today, like uploading PDF documents, but logs, metrics, APM traces. So we call it a search solution.
Great. Yeah, we use Elastic and Unstructured. It's really great. And so what we've seen, at least from our side, of how we ended up in survival mode with GenAI was starting in 2022 and 23, when GenAI really became much more popular and widely used. There were a lot of proof of concepts and use cases that people came up with. Kind of over the last year, we saw these POCs get consolidated. And from last year and going into this year, we saw a lot of prototypes to validate the return on investment. And so this year, we're seeing a lot of bottlenecks and then complexity to bring these into production.
Yeah, and so, Nina talked a bit about kind of what the surviving components are, and I'm going to talk a bit about what the components of a GenAI application are and how all of these fit together. So, we have your data pipelines, which is taking the data that you have. So a big component of RAG is using the data that you own to augment the responses that an LLM is going to give to you. And, one of the benefits of doing that is, first of all, you're using your own data. You can remove any PII through data pipelines like Unstructured. And you can kind of reduce the cost and complexity associated with what you're sending to that LLM, because those all cost money, the tokens you send and the documents you send. So that's the data pipeline piece of the GenAI flow. And then you have your embedding models, and all of the boxes that you see that have the Elasticsearch logo. These are things that Elasticsearch can do. Obviously, there's a big part that unstructured plays, and then there's other frameworks, and orchestration tools that you can use for the other pieces. But the embedding models can be hosted in Elastic, or you can use external models. You obviously need some place to store those vectors. That's Elastic. And then orchestration, you can use things like a LangChain to build your apps. And then there's all of the LLM operation stuff like logging and monitoring. And then, of course, there is the LLM hosting itself, which is things like OpenAI, Gemini, all of those. But this is, when we're talking about GenAI, this is a generic or a general architecture.
Great. And speaking more to that data piece, you often will need some sort of access to your own data, whether it's your company's data, your customers' data. And colloquially, we've seen that 80% of a company's data could be in an unstructured format. And so these different file types could require bespoke pre-processing, and you could often end up with huge teams just for this transformation and the pipeline maintenance. As we've actually discovered, it's much easier to build the connector than it is to keep maintaining it. And so what a lot of companies end up with is this rat's nest DIY data layer, where you have all of these different packages hodgepodge together between your systems of record, where your data starts, and the graph and vector database, where you want those to end up. And so you can end up with like 10 different packages for file transformation, your own scripts for document cleaning, and a lot of other pieces in that pipeline. And some clues to to know if you might be on the surviving side of GenAI would be if you have bespoke data connectors lacking full metadata, if you have complex, low-quality partition, chunk, and embedding setup. If you have this tool proliferation, it ends up being very expensive, even if every component only costs a small amount per month. When you add up 10 to 15 of them, this piecemeal setup can be quite costly. And then this could be you if you're seeing poor search relevancy without semantic understanding, and you feel like your engineering talent is misallocated. So yeah, that's kind of if you have a team that you meant to be building an application and they're maintaining this layer on their own. And so if you're, you can tell if you're thriving in GenAI if you have ready-to-use connectors for GenAI with rich metadata, which Unstructured provides. To thrive, you really want consistent canonical JSON to make access easier, a centralized and efficient tool set, and then highly relevant retrieval, and your engineering team focused on these end user features. And so Unstructured and Elastic combined can save you tens of thousands of engineering hours, so that instead of a rat's nest, you have this really simple flow. You start with your systems of record wherever they are. Unstructured can do all of the ETL and then load the data to Elastic.
Yep. And Elastic is a vector database. So all of the vectors that you generate from either a model that's hosted inside Elastic or an external third-party model, you can store that in Elastic. You can use Elastic's APIs, KNN search, RRF, hybrid search to then retrieve those vectors in an application. And then the observability piece, which is being able to observe your application. So, how is the LLM latency? How much is it costing per token, et cetera, all of the observability that you need. And then finally, you have the LLM that you are, if you're completing a RAG application that you're sending it to do the GenAI response that you're getting back.
Yeah, this stack looks a lot neater to me than the rat's nest. And so to dive in a little bit more on how we've set up ingestion and pre-processing 2.0, in that ETL piece, we have 35 plus different source connectors that we support, largely ones that store unstructured data, 60 plus different file types. And then we offer multiple transform strategies. You really don't want to be throwing a VLM at, a simple text-only document. So we offer a basic pipeline for simpler documents, an advanced pipeline for like more standard PDFs, and then a VLM pipeline for really challenging documents like scanned documents with handwritten content. And we use these transformation strategies in combination with custom pipeline pieces and third-party integrations from Amazon Bedrock, Anthropic, Azure, Gemini, Together AI, and others to turn the original files that were in your source connectors into canonical JSON. And then we offer a number of different embeddings, number of different enrichments. So chunking the JSON, embedding it, offering other custom integrations like named entity recognition or other features coming soon in our custom prompting. So your JSON gets further enriched, and you have this nice JSON that's chunked, embedded, and has 30 plus fields of metadata that then ends up in your destination connector. And we offer some really cool features like change detection. So we would only update files that have changed or are new in your destination connector, and deduplicating on that side as well. So you really don't have to worry about keeping everything up to date once you've set everything up. And we'll have an event-driven detection and processing coming soon as well. And then once your data is in your Elastic connector.
Yep. And so, like we've mentioned, the vector database that you decide to use is an important component of this GenAI pipeline. And there are a lot of vector databases out there. You're probably, you've probably encountered several of them, including Elasticsearch, I hope. And so what I just wanted to highlight is, most vector databases have the ability to store and search through vector embeddings. Some databases allow you to create those embeddings within the platform. What Elastic really aims to do is bring all of the lexical search that you may have been familiar with before this whole world of, GenAI came about, and that's just normal keyword search, incorporating that as part of a hybrid search strategy to really boost the relevance. I found working with customers that, to get purely relevant results from something like an ANN search is difficult unless you have a team that is tuning a model and really making it provide relevant results. If you're using something out there, and if you are using like a model that's already out there to generate embeddings, you really want to employ this hybrid search strategy, use boosting and weights and filtering, and really be able to have control over it. Things like geodata, being able to do date range searches, are important. The other thing that people often consider is having an RBAC model around the data. So, if you need to lock down any fields, if you need to protect any indexes or documents, having a governance kind of enterprise search approach to these applications generally becomes important as they go into production. So those are some of the things that Elastic offers as part of its platform. And Elastic, as I mentioned in the very beginning, important for search, used for search. And we like to say everything is a search problem. Security and observability are all, after all, trying to find some type of data within a data lake. So the only thing I want to highlight from this slide is that the Elastic platform is search, security, and observability. And we have our own integrations to ingest the data, and then visualization and analytics tools to search through that data, and then everything in between to kind of help you find what you're looking for.
Great. And now that we've kind of given you all some context about what we're talking about today, we're going to go through a couple of demos. So first I'll show you how we build that ETL pipeline in Elastic, and then Amy will show you how to do the additional steps and set up RAG within Elastic. And then we'll have time for Q&A. So in Unstructured Platform, if you go to just the start page, we have a lot of information about how to get started, videos, documentation, a community Slack to ask questions. And if you wanted to set up RAG in Elastic, what you would do would be to set up your connectors. So you would set up, let's say, a source connector, and then an Elastic destination connector. And we also have a local connector coming soon that will make it easier just to drop in a file. And for example, in my destinations, I already set up my Elastic connector, and it's super easy. We have this pane on the right side here that shows you where you get the host index name and API key. And I created a little index, and I was just able to find all of the information right up here. So set up the connector in just like a minute or maybe even less if you copy and paste super fast. And then once you've got your connectors set up, creating a new workflow is just as easy. I like to do build it for me and then customize after. And then so here's my Elastic demo. So for my source, I just have an S3 bucket with the US Constitution in it. My Elastic destination that I set up. I'm going to go with the auto partition strategy, which is pretty new. It decides if the document goes in a fast, high-res, or VLM pipeline, and some of these defaults for embedding and chunking. And that's it. I have created my workflow, and then I'm just going to hit run. I already ran a similar workflow earlier today, so I can talk a little bit about what's happening there. It took about 48 seconds, so it should be done probably by the time I stop talking about it. So it goes and finds your input file, it partitions it, summarizes any images, summarizes any tables, chunks, and embeds the data, and then you'll find it within Elastic. And so from my previous run of this earlier, I have the documents, the 35 documents in here, and that one is still in progress. And I'll kind of talk a little bit about how you can also customize these. So I set it up with the easy buttons, and there's different enrichments in here. So I've got image description, table description. I can, swap that out and set the table to HTML or named entity recognition. You can swap out different strategies, like say, you want to use a VLM, and then you can select which one you want to use. And then you can also swap out your embeddings. You can add multiple sources or destinations, or as Amy will show it, you could just do just a partitioning step between your source and destination if you want to further customize those steps yourself later. And so I won't save this because it was still running. And then, yeah, we can just look. Yeah, this time it took 52 seconds, not 48, and my file is in Elastic. And now I'll turn it over to Amy to share her demo of Elastic. You can see what you do once your files are in there.
Okay. So for this demo, I'm going to walk through a document that I ingested into Elastic, and then talk about how to build just a quick chat application with it through some of the tools that Elastic provides. So the document that I chose for this demo is sort of a silly study. It's called The Case of the Disappearing Teaspoons. So it was it's a longitudinal study of teaspoons that have gone missing in an Australian research institute. So there's, I guess this research institute, a lot of people are are stealing or misplacing cutlery, and there was some frustration around it. So they did this study. So you can see, you know, just like like any other research paper, you have your text in paragraphs, and then you have your visualizations with captions, and you have a table. And so one of the reasons that I used this study is I wanted to be able to show how unstructured can infer tables, and you can ask questions of those tables, which is pretty cool, I think. So let me get rid of this. So what I did was, you know, I think one of the questions asked about code. So the great thing about this is there is no code, right? This is all a part of the UI that Unstructured and Elastic offer. There is probably some code if you're creating like this end application, but that's sort of out of the scope of this demo if you're creating a custom application. But here we're just trying to get the data into Elastic. So I have my PDF stored in Google Cloud Storage. So it's stored in Blob Store. And then I'm, like Nina mentioned, just using the partitioner block of unstructured because I'm actually going to allow Elastic to do the chunking and to do the embedding piece, which unstructured can do, but I've decided to just do both of those things with Elastic. But I am having unstructured infer tables, as you can see here, and read the table that's in there. So this is Elastic. I'm right now in my Elastic cluster, and this is what the source data looks like as it comes in. So it chunks up that data. So we're ended up with 87 documents. And if I just explode one of these, you can see that, you know, this one doesn't have a lot of text because it probably just came from a block of from the text. But you can see here, it's creating these embeddings. It's taking the text and it's creating these vector embeddings. And to create those vector embeddings, I am actually using a built-in model that Elastic provides. So it's called ELSER, and ELSER is Elastic's proprietary vector model that comes out of the box with Elastic. So I'm using that to create these embeddings. And the other thing that I need to do in order to get that data into Elastic is map the data. So what mapping does is it says for all of the fields that unstructured creates, I'm going to give them a type. So for example, you know, data source created is a field that unstructured generates, and I'm going to say it's a date. So you don't have to do this mapping. Elastic does infer a lot of this, but I just wanted to be more explicit and create this mapping. Okay, so what do we have so far? So we have taken the data, we've put it into Elastic. We can see that there's all these documents are in here. They're searchable. They're good to go. Now, Elastic has this playground. So what the playground does is it allows you to ask questions of your data. And this is a precursor to building a end-to-end application, which I'm also going to show. But this is just to say, do I have the data in here that I want? And can I ask some questions of it? So the first question I'll ask is like, you know, can you summarize the study for me? And to point out, this is connected to an LLM. This is connected to OpenAI. So what Elastic is doing is when I type this question, it's going to ask the documents that are stored in the database. Can you find ones that are relevant to the question that I've asked? Send that to OpenAI to formulate a human readable answer back to me. Okay, great. So the study aimed to investigate blah, blah, blah. So great summary. And it says the AI grounding was based on 10 document sources. And it actually tells you what are the documents that it used, that it sent to OpenAI so that that answer could come back. And so one of the questions we had was, and I'm going to so can you tell me how many people said I'm just going to copy this for the sake of time. I'd already asked this before just to make sure I was giving the right answers, but I'm going to ask it, can you tell me how many people said they'd stolen a teaspoon? Because if you remember, there's a table in there, and that's what that table, they did a survey to ask how many people have stolen a teaspoon. So this says, according to the study, 36 out of 94 respond, and I can verify, you know, from the documents. Here is the table. You can actually see the table structure that that is the right answer, 36 out of n equals 94. So great. And then there was one more question. Where is the top place? Where is the top place that teaspoons are stolen from? And again, this was also in that table. The top place from which teaspoons were stolen is work. And let's go to our study and verify that that is indeed the right answer. Have you stolen a teaspoon? If yes, from where? Work. Okay, cool. So I do see that it says 22. That one said 10. Maybe I misread the table. But anyway, you can ask questions of it and you can verify based on the actual data, whether that's correct or not. Okay, and so this is all from, information that I'd put in there. And this is not an app. You probably wouldn't expose this type of UI to a end user or customer. So here is a demo that I've built. It's not using the teaspoon data. It's actually using some travel information. So this is a travel customer portal and, like a reservation site or something like that. And I have added documents for my company in this so that when customers come to ask questions, they get answers. And so we'll go to the chat, and this is a RAG-enabled chat, and say, my flight was canceled. What should I do? So, or I'll say, what should I do if I have an accident while traveling? Yep, and you can see that there's a very specific call to contact this email. So if I don't have this RAG enabled and I ask the same question, it's not going to augment it with any of my local information. And you can see that it's just a generic answer. It doesn't have any contact information. It doesn't have a phone number, nothing like that. So this is why RAG is, pretty important. One more workflow that I just want to show is, this is the administrator side of this portal. Say I am a help desk worker and I want to log a new ticket, and this happens to be a customer complaint. So, I'm gonna create a new ticket and say, I had a bad Airbnb experience. My Airbnb wasn't clean and cost too much, ... And I'll create this ticket. So what you can set up in Elastic is you can actually set up a workflow where you can send this data through a sentiment model that you have uploaded. So let me sync so that the new ticket that we created shows up in here. If I give it just a couple of seconds to sync, refresh it. Okay, so we can see that, this is actually the second one. Yep, so we can see here that the predicted, so this was my review and my description, and we can see that the predicted value, the sentiment was negative. And what you might want to do, maybe this ticket gets routed to a tier 2 or a tier 1 help desk person because this customer isn't happy, or there's many other sentiment and sentiment-driven classification models that you can use to basically route tickets. The last thing I want to show is I talked about observability of LLM applications. So for this travel application that was built, and by the way, this is using LangChain, it is using Elastic APIs, and it's using, it's basically a coded up application, but the main part is that it's querying this data from Elastic via the APIs. But if I wanted to monitor the performance of this, you can see here that it's basically telling me what is this LLM costing, what the most popular question is, what the minimum latency is, maximum latency. So when we talk about observing your applications, this is what we mean is making sure that the end user of that application has the best experience. So that is my demo. Please ask questions in the Q&A. I'll hand it back over to Nina.
Thanks, Amy. That is such an awesome demo. It's really amazing what you can do with Elastic. So let's see, let me open up the Q&A and we can get started there. Okay, so starting at the first question from Brian. If I'm ingesting a wide variety of file types from a SharePoint folder structure, is the transform stage switched inline, or do I have to organize my files in simple to complex to better utilize the 3 transform options? So going back to that workflow that I had set up and the 3 transform options, the short answer is you don't have to organize your files at all. The auto partitioner is going to automatically select the best strategy for your files, and it's going to do that at a page level. So let's say you have a document that has one page that's just text, and the next page has a really complicated image. We're going to use the fast strategy for that simple page, and then the VLM for the really complex page. And so there's really no need to organize your files to use the auto strategy. However, something that you could do, for example, if you know that you have your own preference for which strategy to use, is you could have like separate directories and set those up as separate sources with separate workflows. But I think the auto strategy should be able to detect that for you pretty well. And then let's see, Jack asks, do we have a GitHub repo for the demo? So for unstructured, we have our platform available as a UI, and then we also have a platform API that's available in our documentation that I can share.
Yeah, and on the Elastic side, that Elas travel demo specifically isn't in a GitHub repo, but we have a Search Labs blog. And I'm putting the link into the chat that has a RAG example that is very, very similar. It just isn't branded Elas Travel. So that should give you what you're looking for.
And I shared the platform API documentation in the chat as well. I see a question from Jack. Could you share the input source of your data? Was that, I'm not sure if that which of us that was directed to, but on our side, like the sources, you can link any source that you had set up already, and you can add another source as well. And then question from Jack, how many documents could be processed using the unstructured free trial in one go? So our free trial is 14 pages, 14 days with 1,000 free pages per day transformed. Another question, how does unstructured local versus unstructured cloud differ? Can we do all of what was showed using the open source version? So I'll talk about a few different ways to use unstructured. So we have the open source version, which really just focuses on transform and does not have some of the more advanced options. The high-res pipeline there has not been updated in a while, and it has the fast, which is great for text files. And then it has our connectors, but it doesn't have any of the advanced enterprise features, since we suggest that version for prototyping and the platform or platform API for production. And so it wouldn't include it might include some chunking in the open source. It does not include embedding, does not include any of the enrichments, doesn't include table summarization or image summarization. And then for the local versus cloud, so we have on-prem and in VPC hosting. And so you would have the exact same platform or platform API that I demoed or linked if you want to set it up in VPC or on-prem in Kubernetes. The only difference is that instead of us doing auto scaling, you would set up your own compute. And so we can also work with you to help you set it up to be as fast as ours, or even faster if you just have a really high computational needs. And then let's see. I think this next question is for for Amy. Oh, Amy, I think, typed an answer.
Yes. I think it was about, what if I'm running a local LLM model? You can run a local LLM model, and you can point the RAG to a local LLM model, which a lot of people do if they don't want to send it to a public endpoint, right? They want to keep everything in a private environment. But you still need a tool to ETL the data. You need a vector database. We're sharing our platforms to do that, but you typically need these tools.
Another question here, question from Drew. Can you talk about how unstructured helps create entity relationships to embed an elastic graph database for GraphRag? So we don't currently have GraphRag, or I guess I'll let Amy answer the part about Elastic. We know we have GraphRag enabled for AstraDB and Neo4j. And for example, for entity relationships, that can be used with any destination connector. You would just select named entity recognition. You can, right now we have that set up with Claude 3.5 Sonnet. And then we have a default prompt that I selected here, but you can also, oh yeah, here's where you can change between GPT-4o or Claude 3.5 Sonnet. And then we have our default prompt here that says like which entities we're looking for. And then also the response format, where we have like the entity name and entity type shared in each blob, and that can be tweaked as well. But yeah, I guess Amy, curious if Elastic is able to leverage this kind of information as well.
Yeah, so Elastic is not a graph database. It is a document database. So typically if people are doing graph type queries, they will integrate something like Neo4j, great example of a graph database in there. There's connectors out there for Elastic to Neo4j and mappings between those, but Elastic isn't a graph database. So.
Great, thanks. And then there's a question from Frederick. Can you talk about more about the change detection document deduplication? Yeah, so in our workflow here, we have our sources and our destinations, and we also have our settings here, for example. So you would, for the change detection, you would make sure that you don't have reprocess all files selected in the settings, because that will just rerun everything every time. And you could set up, for example, a repeat run every hour. And so if I set up this workflow like this, every hour it would run. And if a file has already been processed, it will ignore it. But if a file has been modified, we'll see that in the metadata. We're not looking at the file itself. We're just looking at the metadata. So if it's been updated in that last hour, we're going to rerun that. And then we also are going to find in the destination based on the metadata. Again, like we really try to not look at your data itself at all, just operate on the metadata in this control plane, which is what's accessing the files, and also writing to the destination. So there, if we already have that file written, we're going to delete those for the deduplication and then write the new ones. And then also if you, in the last hour or however you've configured your schedule, if you've added brand new files, then those will get picked up, processed through the pipeline, and written to the destination like new files.
Oh, sorry, were you still answering this one or another question?
I was going to go to the next one. Yeah.
Okay. So I actually just answered one and said I was going to show is it possible to show the configuration of Elasticsearch index, trying to understand when new doc is ingested in Elastic, how it gets connected to unstructured? So I'll quickly just show really quickly. So I think I mentioned, so the key thing for getting, I don't know if you can see this, but move this over here. Configuration of Elasticsearch index, trying to know how it gets connected. Yep. So with unstructured, the thing that you need for the connector, let me go back to the connectors, is a destination connector. This is an Elastic. What it needs is an index name. That's pretty much it. And then all the security stuff, but it just needs an index name. And so what you're going to do is on the Elastic side, you're going to create that index. And like I mentioned, you know, I think it's good to create a mapping up front to tell it, you know, and specifically because I'm using Elastic's embedding model, I want to say the text that is coming from the text field in unstructured needs to be run through the model. So create the semantic text representation of this text. And in that search labs, there's a bunch of tutorials on how to do this, but the main thing is that you're creating a destination connector, you're creating the mapping, and those are the two things that you need to get the data into Elastic. Hope that helps.
Yeah, great, thanks. And then I think you're typing an answer to the question about tutorials demonstrating the use with code.
Yeah.
Next question from Nicola. What is the best way for monitoring the costs of the workflow, i.e. unstructured and Elastic? Is there a UI in both from which you can see an aggregated cost and breakdown based on usage? So yes, unstructured platform has you right in the UI in your settings, you can see what your costs are so far. And then in Elastic, Amy, do you have something similar?
Yeah, for costing, so Elastic has a cloud a hosted way that you can deploy a cluster, and that has costing information for the cluster itself. I showed you the way to monitor it if you're using an LLM. That would plug into the LLM APIs to understand the cost. So there are ways. It's complicated when you're using a couple of components, but Elastic itself does have a way to query cost and understand how much you're using.
Great. Question from Roger. These would be great for accessing all types of data across public/private locations for training LLMs. Is that true? I think that might be referencing unstructured. And so, yeah, so on the source side, we are bringing our number of connectors we have supported in the API up to speed on the sources here. And we have potentially some exciting new integrations coming soon, allowing for access to even more data. You can see our full list of sources in our documentation. And so, yeah, you can combine all of your different data in one place. Let me find the Q&A pane again for the next question. Okay. Question from Innovation New Mobility. I am building a RAG to ingest geospatial data, sensor data from cameras, and complex PDFs. What is the best way to use the Elastic unstructured combo for this? Elastic for geospatial and unstructured for complex PDFs. So yes, I will say that unstructured will definitely be great for loading those complex PDFs into Elastic. I would say we don't do as much for geospatial and sensor data. And Amy?
Yep, hold on, let me go back to the question. To use Onion for this. Yep, so Elastic for geospatial data, Elastic has a geo database. So you can do geospatial queries, like find me all of the stores within a mile of blah, 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 polygon intersections of coordinates and areas. So I would say with Elastic, the mapping is a great way to take what unstructured is sending and then mapping it as a geo data point that comes out of unstructured. So anytime you can set up pipelines to say, oh, I see coordinates or I see a city, you know, map that into a geo data element.
Oh, that is really neat. That's a really great combo. Question from Jack. At what duration does data from S3 get pulled? Can we configure that? So yes, in the workflows, in the workflow settings, you'll be able to set the schedule anywhere from every 15 minutes to monthly. And we also have event-driven processing coming in the next month or so. And so you wouldn't even need to configure this repeating schedule. You could just have it update based on when a new file gets loaded or whatever event you want to trigger based on. Question from Thomas, does the unstructured platform provide connectors for Elastic and Confluence or Microsoft SharePoint? Yes, we do have both of those. And let me see if they're, let's see. Yeah, Confluence is right here. And SharePoint is right down here for our source connectors. Question from Jack. Nina, how do we reduce the latency of uploading a doc to creating the embedding? 48 seconds is a lot for real time, need it under 5 seconds. So yeah, so one thing I forgot to mention in my demo is that actually, so yeah, one thing is that the workflow that I set up had a lot of different steps in it. Actually, embedding is often the longest step. The partitioning is really fast. So the demo actually is like less impressive when you're running a job for just one file, because a lot of these are just, the time is just the pods coming into action. And so I've run, I think last time I ran like over 1,000 files with the VLM transformation in under 30 minutes. So we really are scaling a lot with concurrency based on the number of files you've loaded. And I'm sure, that was like over a month ago. I'm sure it's gotten even faster since then. So I would say like, yeah, for one document at a time, this is kind of around the speed you'll be seeing. But if you're processing a lot of documents at once, it's going to go a lot faster. And then also for reducing the latency, if you want to deploy this in your own cloud, or if you want to, let's say like, yeah, as I mentioned, embeddings are like the most time intensive step. You could customize that yourself in your own deployment. Let's say if you're working with our sales and solutions teams, they can help you customize that piece. Or you can make a future suggestion for a different embedding provider that might be faster. But I kind of noticed that at least all the ones that we have so far, that does tend to be the slower step. Another question from Jack. I already have a SharePoint data getting indexed directly to Elastic. Can you show how I can bring unstructured part to the current system? Would I have to rerun my docs from scratch? Yes, so if you want that change detection for those specific files, you would need to rerun that workflow, because it's that workflow itself that's detecting if files have changed or not. They're not going to know about your data that's already in there that's been processed in a different way. And then I also saw some folks had some questions they shared into the chat. So I'll just kind of scroll back up to some of those. Oh, and tutorials from Unstructured. So we have a few different places where you can find tutorials. We have our previous webinars, and those include some as well. And then if you go to our website and our documentation, we have this example code. And that has all kinds of example notebooks using our API or our platform, and showing like different functionalities and combinations that we have in our example code section. Question from April. I already have data in Elastic that is used with the business rules app, but it's complex. I'm looking to build something that will validate criteria of an input and output if whether or not it meets the criteria. Amy?
Sorry, can you repeat that question? I was answering another one.
Oh, that was the question from April in the Q&A from
Oh, there we go. I already have data in Elastic that is used with business rules app, but it's complex. I'm looking to build something that will validate criteria of an input and output if whether. I'm not sure what validate criteria of an input and output is. I will interpret that as you want to know if what you're bringing up through a search is relevant or not. there are a bunch of relevancy tool benches that, so the one thing is in Elastic, you can ask it to explain how it got to a certain, search result. And the way I work with customers that are building search apps is we always look for a what we call a judgment list or a golden list, which is to say, if I ask a question, what am I expecting as the output? And then that search is going to require tuning, whether it's on the semantic model side or if it's on the lexical side and you're doing a hybrid. For example, do we need to boost certain things? Do we need to, add filters, things like that? But first, you need to know what you're looking for and in order to build good search. I hope that answers that.
Yeah, thanks. Question from Faraz, is there any special pricing for startups? So on the unstructured side, if you go to the enterprise link here, you can contact our sales team. And we offer, in addition to the pay-as-you-go pricing from the self-serve platform, you can also connect with our sales team and prepay, and that offers roughly a 50% discount. It's not special for a startup. It's for anyone that wants to kind of prepay and set up their billing that way. And Amy, does Elastic have special pricing for startups?
We don't have special pricing for startups, but there are, like, if you use the cloud, it's a metered usage model. So if you have a very small cluster, it's frequently fairly cheap to just to create a cluster.
Great. A couple of questions from Jack. Slack connector and GitHub connector. Yes, you can see those, which ones we have in our documentation here for platform. We have our sources over here listed. Looks like GitHub and Slack are not in the platform yet, but they are available in our API. We have more of our sources available here. So you can see on the left here, we've got GitHub and Slack. And those are all coming soon to the platform as well. We're just kind of bringing the API and UI to parity over the next month or so. And how does unstructured OCR compare with Gemini Flash 2.0? Are there any benchmarks for OCR? I don't know if we've published any of the benchmarks more recently. I would say something like Gemini Flash 2.0 would be more comparable to our VLM approaches that we would recommend for more challenging documents. I think over simpler ones, the OCR could be quite comparable still. And we are planning to integrate Gemini as well as one of the partition options. So soon you'd be able to just use that one. We are working on a blog, I would say probably coming out next week, that kind of compares high res, fast, and VLM on a few different document sets that will help people understand how the performance in downstream application can be affected by which strategy they're using. Next question, is the unstructured VLM capability to use to extract info from Google Street View, or would Elastic, or would this be another provider? I guess if you have your files, I mean, if what you're looking for is just a description of what's in the image, I think it could be useful for that. I'm not sure, does Elastic have any offerings there?
No, we don't. And I think someone else asked kind of what is the difference if Elastic does chunking. Unstructured's full focus is on building data pipelines. So they have things like inferring tables and reading images and extracting stuff out of them that Elastic doesn't have. Our focus is on making those searchable. So you would use unstructured here.
And then Amy, how does ELSER v2 compare with OpenAI's best model? Any benchmarks available?
Yeah, we do have benchmarks. So ELSER is not an LLM model. It's to create vector embedding. So it's not generative. I guess OpenAI is also an embedding model. So I apologize. But yes, we do have benchmarks. I can post those in if you give me a second.
Thanks.
Yep.
Some other questions that came in the chat. Amy, is the code of ELAS travel open source?
I think I answered that one. So that one isn't, okay. But I think I posted in the chat a link to our tutorials example, and there's one in there that is very similar.
Great. And then another question. Can Elastic be used for real time, like this Zoom meeting, and provide AI feedback?
Can Elastic be used for real time? Yes, it has near real time ingest. Like people will send, like great example, monitoring a streaming service for performance degradation. So for example, for this Zoom meeting, you could take the audio and the chat and what's being shown on screen, use unstructured to parse all of that, send it to Elastic. It now sits in the vector database and you can ask questions of it, or have an app that is kind of programmed to ask questions periodically. So I think the answer is yes, that it can be. You'd have to create that application.
Yeah, and we have a customer for our for unstructured that uses it to process like a real-time screen feed, and they just process it as a series of images. And they found that that works really great. A question from the chat from Jean Patrick. When you extract text from your document page to JSON, if you want to extract metadata from the same document, how do you manage both data to your database? Is unstructured managing data classification automatically in your database? So we'll extract the text and other elements from your document, and then that will be in the JSON as a text field. And then all the metadata will be in a metadata field. And so that will get written to the database as well. And then a question from Sun regarding the tutorial. So they start you from scratch to show the breakdown from the beginning. Yes, for some of ours, our notebooks are, we have introductory or advanced for the topics that we cover. And then we also have blog posts that are potentially more introductory that also share information on how to get started. And yeah, Amy, for your tutorials.
Yeah, I wrote a specific one on Elastic to unstructured to Elastic, so I put that in the chat.
And then another question, Nina, did you have to set up any index schema when specifying the source of your data? For the source, no, I don't have to specify anything besides let's say like for S3, all I had to specify was the bucket, the AWS key, and the AWS secret key. And that's all you need to include for a source. It's just the credentials and where the data is. Okay, and last question for Amy. Let's say if you had to add new fields to Elastic, how would you add them?
So if you had to add, so you can do dynamic, there's a way to dynamically detect fields as they come in. It's only going to be for the new data. If you want to add fields to older data, you do have to re-index. So you don't need to ingest the data, but you'd have to do an operation called re-indexing, which you can do inside Elastic. But essentially, you do need to reprocess the data to add new fields if you want it on the past data as well. If you just want it from that point onward, that's fairly straightforward.
Oh, and one other quick question, are Elastic and Unstructured FedRAMP compliant from Innovation New Mobility? So we have a federal team, so I think they would answer those questions better. If you reach out to our enterprise team, sales@unstructured.io, they can very quickly link you to that team and they can answer more questions about federal. And what about Elastic?
And Elastic is FedRAMP moderate. We're in FedRAMP moderate.
Okay, great. Well, thanks everyone for joining us and sharing so many questions. We're at the very end of our hour, and we hope that you learned some things today. And thanks for joining. Bye,
Thank you
everyone.
all. Bye.